In the last video, we discussed interrupts and the fact that interrupts are very useful in letting the processor do its thing and only being taken away to go process an event that has happened, and it doesn't have to sit there continuously checking to see if there is any events out there. An analogy that was used in that video was you're at home, you're working on whatever task you have at hand, and when a doorbell rings, you'll go to see if somebody's out there. If the doorbell wasn't there, and you were waiting for someone to come and you wanted to open the door, you had to constantly go there and check the door. With the doorbell causing the interruption, you don't have to do that. You can continue doing your work, and on that rare occasion that somebody's at the door and rings the bell, you go take care of it. So it's kind of nice. And that same facility, that doorbell interrupting your work, in PICmicro we have 3 pins, pin interrupt 0, interrupt 1, and interrupt 2, which allows that kind of interruption. In addition, the PICmicro interrupts allow us to have high priority and low priority interrupts. And the nice thing about that, so let's say you have a processor and the processor is one processor is responsible to turning the light when somebody walks in the door, and another processor is responsible to watch if there's a fire around the building. So which one do you want to be able to interrupt the other one? Obviously the fire has a higher priority, so you want to be able to interrupt the low priority interrupt and take care of it. And that's why there's a high priority and low priority interrupts built into these devices. So what we're going to do in this example is actually get a practical look at what the code looks like for a very, very simple case. And what we're going to do, we're going to go together through this code and talk about some good practices in the code, and also try to figure out how the interrupts are actually used when you're starting to write the code. So this particular code, we don't know what it does, and that's the job of what we're going to do today. First thing is, when you write a code, it's really important to have a header on the code which tells the user what is this code is, who wrote it, when was written, any other hint you want to give them. Sometimes people even put enhancement in the future, any concerns, any potential pitfalls, things like that can go in here as well. The other one is, for the PICmicro code, we have to say which PICmicro we are using, and this instruction takes care of that. This is good practice in saying what is the base of the number. So even though I have 0x80, because I say the radix is hex, if I just write the number 80, it would also see it as a hex 80. As long as we're talking about, if I put a dot here and 80 in here, then this number would be a decimal number in base 10, not decimal in the fraction point, but in the sense that 80 base 10, and this. But if I leave it just a simple x80, that is that by definition, because I said the radix by default is hex, this would be a hex number. So, some side note. Did some defines, and then now these, if you recall, when a reset happens, we jump to location 00, and this go to is actually sitting at location 00. This go to is location 08, and this go to is setting as 0x18. This is the low priority. So when a low priority interrupt happens, which means the pin corresponding, to the high priority interrupt, the pin corresponding to the high priority interrupt transitions either from low to high to high low, high to low, or low to high, then this interrupt occurs. Now, as you recall, you are able to change it from one, make it a falling edge or a rising edge trigger. And then if it's a low priority interrupt, set to low priority interrupt, then we're going to jump to location 18. And notice how this is done. Instead of writing the code in here, because you would have, if you write the code right in line and it gets longer than it needs more than 8 bytes, then it's going to run over this and mess it up. So what we're going to do, we're just going to simply jump in to start L, which is down here. So this is where, when a reset happens, we'll end up in here. And then when a high priority interrupt happens, we just jump down here. And then when a low priority interrupt happens, we jump in here. Great. So now reset, let's say reset has happened. Okay, so what are we doing? Reset happened, we're going to set count A to 0, and we're going to send count B to 0. Great. And then we have to initialize the I/O. Remember that interrupt 0 is really RB0, interrupt 1 is RB1, and interrupt 2 is RB2. So we got to make sure these are input so we can actually see the interrupt. So as before, we have to make sure that all shared I/O is set to digital, and the way we do that, we put 7F in at COM4C1. And then we only need bits for an interrupt, bit 0, bit 1, and bit 2 of port B set to input. But since I don't know what else I'm going to use it, usually if you don't know if it's going to be input and out or output, it's better to set them all in input to avoid conflict at the pin. So I'm putting that in trash and making all of those inputs, which is great. Now I have to enable the interrupt. Remember, interrupts have many levels that you have to, there are a couple of things you have to do, three things that you have to do up front, regardless of which kind of interrupt you want, peripherals or otherwise. So in this particular case, we have to say enable all peripheral interrupts, enable priority interrupt. And the way it's done is by doing this. Now, this is really cool because notice I don't have to say pin 1, pin 2, or pin 3, because I included this file. This is a wonderful file to include. All of the SFR registers have already been defined for me. All the bits in the registers have been defined for me. So as long as I know what the name of the bit is, I don't have to remember where it is. So the reset happened. I'm going through here. I set port B2, and I enabled this has to happen. And I enable the priority level, enable the peripheral level. And notice one other thing I have to do globally is I have to enable all the interrupts. So these three have to happen regardless of which peripheral interrupts you want to enable. Okay. Now, then I say, okay, let's see what they did. They said, okay, I want interrupt 0 enabled. Great. So interrupt 0 is enabled. Now, do you remember interrupt 0, if it's enabled, what's the priority, low or high? Well, hopefully you said interrupt 0 can only be high priority. We do not have a way of setting it to low priority. And then next one they are doing, they're enabling interrupt 1. Notice they don't seem to be using interrupt 2. That's fine. Interrupt 1, and then interrupt 1, the way they set it can be set to low priority or high priority. By clearing this bit, they set it to low priority. If you want to make it high priority, you just set that bit. So this one is in low priority, which means what? Which means when this interrupt 1 happens, we're going to end up in location X18. And then when high priority, when interrupt 0 happens, we're going to end up in high priority address, which is 08. Okay? Oh, and then you always got to make sure that the flags, the corresponding flag for interrupt 0 and interrupt 1, have been cleared before you start. And after you process an interrupt, you also have to clear it. Notice now, by the time we get to this point, all the initialization for interrupt is completed. We just turn all the interrupts on because we're ready to go. And if you now, so let's say we come here and we haven't got an interrupt yet, nobody's toggled that bit interrupt 0, interrupt 1, and interrupt 2 pin, which means the processor sits in this loop and goes back and forth. Now, if your processor needs to do something, you can gotta put it in here and they're gonna keep doing it. As soon as an interrupt happens, where the location, the next instruction that was gonna be executed, is going to be put on the stack. The address of the next instruction to be executed puts on the stack, and we jump into whether it's a high priority or low priority. So we either jump up here or we jump down here, whether it's depending on whether it's a low priority. The way it happens If it's high priority, you're going to go to 08, which goes to high priority. When you got low priority, you jump to 18, which goes to low priority, so you end up down here. And all it's doing, so this is rather simple. For the high priority, increments count A and clears the flag. If you do not clear the flag, this interrupt will never occur again. And then you do not jump back to your main code. Remember, when a main code got interrupted, the address of the next instruction was pushed on the stack. So when you do a return from interrupt, it basically pulls that location off the stack and goes to it to execute it. If it's a low priority interrupt, we're going to do one check to make sure that that interrupt 1 is indeed the one that's happening. Maybe it's interrupt 2 or whatever else is happening. If it is, we're going to branch to interrupt 1, increment count B, very exciting. So if low priority happens, count B gets incremented. If high priority happens, interrupt A, count A gets incremented. And then what we're going to do, we're going to clears the interrupts again, and then we return from interrupt. And that's it. And remember, we return to the next instruction that was supposed to be executed during the interrupt. Now note, when an interrupt happens and you're in the middle of an instruction, that instruction will be completed before it jumps to location 8 or 18. So when it comes back, the next instruction is indeed the one it is to execute. Okay, so just as a quick overview of this piece of code, it's doing some of the prep work that we need to do, and then we are using the include file, so we don't have to anymore say where the port B is, what the registers are, or any of that stuff. It knows exactly where all the SFR registers are. We are allocating a couple of memory locations to count A and count B, and then we're setting for reset vector to go to start L, for high priority interrupt to go to the high priority, and for low priority to go low priority. And notice our main body of the code starts here because we don't want to have too many codes up here to avoid running into the next vector. Okay, and then that is, I think, pretty much it. And then there's the rest of the code in here. That brings us to the end of this example.